Great, it's recording now. So let's talk about this Desmos activity 2 first. In case you want to go straight there, here is the link. You can just click in there and then you will be looking at this screen, right? Transforming function. This is Desmos activity 2. Or you can go to our website, go and click on the tab Desmos, it will appear there too, right? Or even in black. All right, so if you have a Desmos account, you may sign in. That way your work will be safe, right? And you can improve it later. Hughie, welcome. Or if not, just continue without signing in, right? And later you can go back there. All right, I'm gonna just start by typing the name of a great mathematician, Newton this time. I'm gonna enter like Newton there. You should write your first name, last name, so I can see your work in my dashboard, right? Okay, great. A bunch of challenges as usual, guys, that you should go through, right? I'm gonna go over some of them. This deals with transformations of functions, okay? So let's see. Welcome, Savannah. We just started with Desmos activity 2. Let me post the link here in the chat so you guys can just click in there and go into Desmos activity 2, which is this. First challenge, first question, it says, describe in words how you would transform the black function into the red function, right? So try to figure that out. Julie, welcome. We just started with Desmos activity 2. Let me post the link for you to click and then you will be in there. Great. Any of you guys could tell me what is needed to do to this function graph here in black to end up with this other function here in red. Hint, clearly it's about doing a couple of translations, right? But what are these translations? So anybody could write on the chat what is needed, how many units to the right, how many units to the left or down, up, right? A couple of shifts are needed, but what are those shifts, those transformations? So feel free to write it on the chat or in your Desmos activity also, right? And when you click submit, I will get to see when you click share with class, right? Yeah, you can write it. Great. So for example, I explained, right? It's a good idea to basically pay attention to this point, right? Important point, and try to see where this point will end up here. Look, you have to move this point 3 units to the right, and then 1, 2, 3, 4, 5 units down, right? 5 units down. So feel free to write it any way you wish, right? In your own words. So I would say 5 units to the right, comma, 3 units to the right, right? 3 units to the right is 5 units down. Look, 1, 2, 3 units to the right, and 1, 2, 3, 4, 5, 5 units down. 5 units down, 5 units down. This will be enough, right? That's me, right? And we should be able to get there, right? See, shift down 5 units, shift right 3 units, right? Excellent, excellent, right? Here, let x is subtract 3 and f of x subtract 5. Excellent, excellent. Different ways to express this, right? Feel free, guys, to write it, right? The way you want it. And when you share your answer, you will get to see what your peers, your classmates wrote, and then compare, right? And with that information, you can move on, right? After answering that part. Next challenge is describing words how you would transform the black function into the red function we did, right? So let's go to the next challenge. Use algebraic notation to describe how that to transform the black function into the red function. The black function is f of x. This is the graph of f of x. It says someone attempted that task below, but they were unsuccessful. let's start by fixing their work, right? So what is needed to go from here to here? We all agree, right? It's just a translation of 3 units to the right and 1, 2, 3, 4, 5 units down, right? It's just pure translation, right? So this number 2, which is a distortion, right? It's a stretch, is not needed, right? It's not needed. So I think they should be removed. So now it looks better, right? But what else should we fix there? Anybody could tell us? What else do you think we would fix? I removed the 2, looks better now. But what else? How can we change the 4 and the number 3 there for the black graph become the red graph? Yeah, in order, I see in the chat. Shift down 5 units, shift right 3 units. Excellent, right? Shift down 5 units. To shift down 5 units, remember, we have to subtract 5 from the output value, right? From the output value. That's good. You see? Now, but to shift 3 units to the right, remember, these changes, the ones that affect the input value X, are counterintuitive. So instead of +3, you should write -3 here, right? You agree, guys? Yeah, I think, and you can see perfect match, right? Don't worry if you make a mistake. Let's say instead of 3, you put 2. Not enough, right? Then you fix it, 3. 3 is the one, look, perfect fit, right? Yeah, from here to here. And that's it. Submit. And then we're ready for the next challenge. Great. Next challenge. Says use algebraic notation to describe how to transform the black function, this one, f of x, into the red function, into this, right? The black function is f of x. So anybody has an idea how you can transform this black function f of x into this red function? By what type of transformation? I'm going to give you a hint. Notice this point 0, 0, it stays pinned, it stays the same, doesn't move. But this guy moves, this output value 2 becomes 4, twice as much, right? This output value 2, 4, 4. The output values are getting double. This output value 1 becomes 2, right? And so on. This 0 doesn't change because multiplying a number by 0 is still 0. But the question is, guys, by what factor do you think I should multiply this f of x? F of x is going to be multiplied by a factor, but anybody could tell me by what factor? Is it 3, 2, 4? The one that I'm going to write here in front of f of x? It is a vertical stretch, right? By what factor? I see. Very good, Jing. Excellent. Good reason, guys. 2, right? 2. 2 multiplied by 0 is 0. Nothing happens there, but 2 multiplied by 2 will give me 4, right? 2 multiplied by 1 will give me 2, right? Consistent, so very good. 2 times f of x, right, is this. And in order to see that, just submit, and you will see that it's a perfect match, right? Don't worry about making mistakes, guys. Let's say instead of 2, for some reason you believe it's 4. This will tell you, look, too much, right? Too much. Maybe 3. Maybe 3 is still too much, but 2 is the one, right? 2. Play around with it. Play around with it, and then eventually, look, you will get a perfect fit here, right? There you go. Twice as much. Great, excellent. This was challenge 3. Let's go ahead with challenge 4. This one now. Look, this is the original function, f of x, and this is where you want to end up, right? Green, red function. So use algebraic notation to describe how to transform the black function into the red function. So anybody could tell me what kind of transformation is this in the chat? Yeah, very good, Jingjing. Inverse, right? So basically, it's like putting a mirror here, right? A mirror and that we call reflection, right? Remember, reflection. And not only that, I can say that the reflection, since the mirror should be positioned at the x-axis, is a reflection about the x-axis, right? But what do you do to get a reflection about the x-axis? Well, we use multiplication by -1, right? Julie, excellent. Julie saying -1 times f of x, which is minus f of x, right? F of x. Excellent, excellent. Look, this minus f of x will turn these positive output values into negative output values, right? 0 will stay there because -1 times 0 is 0, right? This point, the x-intercepts, they stay pinned, they stay there. But the other values, 1, positive 1, multiplied by -1 becomes -1, right? Positive 1 becomes -1, positive 2 becomes -2, right? And so on, right? All the output values positive here become negative after this transformation, right? And to confirm, hit submit and make sure that you get a perfect match here, right? Exactly there. Excellent. Great. This is transformation, reflection about the x-axis. Great. Let's continue with more challenges. Another one. Use algebraic notation to describe how to transform the black function into the red function. And feel free to play around, right? Clearly, again, we are talking about a vertical stretch, right? Vertical stretching. Because notice this 0 value, output value 0 stays there, multiplication of a constant by 0 is 0, but this output value 2 becomes a 1, right? This output value 1 becomes 1/2, right? 1/2 right there. So what's going on here? Well, there is a clear transformation. Anybody could tell me what is the number I should multiply f of x by to go from the black function to this red function? What is the factor? Excellent, 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 Julie. Yeah, 1/2, right? 1/2. Yeah, and again, guys, feel free to play around with this, right? You don't have to get it right at the first try. Let's say I'm saying 1/2, perfect match, right? But let's say you thought it was 1/3. Well, this most activity will help you out, because if you saw it was 1/3, looks too low, right? Too low. But if you fix this to 1/2, perfect match, right? Perfect match. Excellent, right? Because the output went from 2 to 1. They're getting halved. Excellent, excellent. So let's move on. Let's see more. What about this one? Use algebraic notation to describe how to transform the black function into the red function. Notice the black function here, red function here, clearly is a horizontal translation, right? Not only that, look, 1, 2, 3, 4, a horizontal translation by 4 units, but how do you write it as a function or in functional notation? F of x, and something must be written there, right? Together with this x. Is it plus or minus? Anybody could tell me what I should write here for this to happen? Is it -4, +4? Yeah, very good, guys. I see students. Jing, excellent, excellent. Turns out these horizontal shifts are counterintuitive, right? Counterintuitive. Yeah, you see 1, 2, 3, 4 positive on the number line kind of hints to the right. But in reality, you have to do the opposite, right? So you have to do x minus 4, right? Yeah, and you close parentheses there. And then, of course, check, right, if this is the right way to do this by submitting your answer, and you see a perfect match, right? Let's say, guys, you first believe that it was plus, right? But when you submit, look, where it takes you to the left, right? Because it's counterintuitive. So then just fix it, right? This is minus, right? Play around with it until you are 100% sure that this is the right transformation, right? Yeah, this is the whole idea of these activities, guys, is for you to play around, to confirm your knowledge and to reinforce your knowledge so that when you take the exam, you will be absolutely sure. All right, great. So this was challenge number 5. Let's move on. Yes, now go to the next challenge. Let's see what's coming up. Aha, this one. Anyone could tell me, right? What is the transformation here in functional notation to go from this function f of x in black to this function in red? Yeah, great. I see. Lucero, Jack. Very good. Good thinking, guys. Good thinking, right? Vertical shifts are very intuitive, here I can see 1, 2, 3, 4 down, right? So we follow our intuition. It's just 4 units down for all the output values, right? An output value in a function is represented by f of x, right? This is the output value. So you just have to subtract 4 to each output value, and this is what you should get, right? In order to confirm, submit, and that's it, perfect match, right? That's it, right? Yeah, and if you don't get a perfect match, do not panic, just try other transformation, eventually you should get it, right? And try to understand why. Great, so we're good. Let's look at another one. This one a little bit tricky. What function or what transformation, better said, or transformations are needed to go from this black function to this red function? Can you figure this out? Hint, look at this point, where this point ends up, right? And then try to translate it into transformations. Yeah, I see Jack. You got it, Jack. Very good. Excellent. Yeah, Savannah, also great. Yeah, Lucero, excellent. Very good, guys. Very good. Yeah, I think you have mastered this topic of transformations. Excellent. So, the idea is, right, if I trace this point and see where it ends up, look, notice this point first goes 1, 2, 3, 4 units to the left, right? And right after that, 3 units down, right? Again, 1, 2, 3, 4, 4 units to the left, 3 units down. For you to shift this graph 4 units to the left, you have to consider here +4, right? +4, Professor, to the left. Yeah, remember, changes associated to the input values are counterintuitive, right? So 1, 2, 3, 4 to the left is achieved by using x +4 here inside the function. Now, the vertical shift, however, is intuitive. So intuitive, 1, 2, 3 down should be -3, right? -3. Yeah, excellent. So now to confirm what you just did, click on submit, perfect match, right? Perfect match. If you messed up somewhere, let's say instead of this 3, you wrote -2, you will see it. Look, it's not enough, right? The translation vertically. So you add one more and then you will get it perfectly. So good. Very good, guys. Very good. Let's move on. Let's do one more. You see. This is very tricky, guys. I'm gonna give you some time, okay? Try to figure this out. It says use algebraic notation to describe how to transform the black function, this one, into the red function, right? Yeah, notice it might not be enough just to shift it horizontally, vertically. You may need something else, right? Something else. Yeah, so try to figure this out. Play around there in your Desmos activity and see which one gives the perfect match. I'm gonna give you a hint. Start by flipping this, perhaps flipping this, and then It might even need a vertical stretching, right? It's really tricky. Maybe 4 transformations probably are needed, but little by little you can get them. Aha, I see Julie is proposing the following. I want to check that out. See, let's test it. Julie is proposing the following, right? -2. And I think the minus is needed because notice this is being reflected, right? And then besides that, there is some vertical stretching. So x -1. And then there is some shift of 1 unit to the right, right? Excellent. It might work, but let's check. Submit. Perfect, perfect. Julie, you made my day. Excellent, right? Excellent. But let's kind of now explain step by step, right? Kind of how we got this, right? Excellent. That's it, right? But let me explain. One way to go over this is perhaps you can start with the reflection. Let's start with a reflection. Let's see what we get. Look, minus f of x and submit, right? You submit and look, see, it brings it over here, right? Yeah, now perhaps then this corner should be down here, right? 2 units down, right? But also notice that this guy is not parallel to this, right? It's not parallel to this. So you may have to use what is called vertical stretching, perhaps by a factor of 2. Let's see. Better, right? You see? Parallel now, parallel. Now what is left is just to shift it to the right, right? But how much you must shift it to the right? Look, just 1 unit, right? 1 unit, right? -1, right? This is one way to do it, right? You don't have to come up with this formula all at once, right? You can do it little by little and look perfect match, right? And don't worry, if you messed up, let's say you thought that this was not 1, but 2, it will tell you because it will go too far. No, 1 unit less. Okay, 1 then, right? So play around with these guys, create your account in Desmos, and then improve your answers, right? Improve them. Very good, very good. Yeah, I think we can do one more and then go to a lecture. Okay, so one more here. Yeah. This one very tricky too. Try to figure this out. Again, perhaps you are gonna need here reflection, and then some shifts, and you may even need vertical stretching. Why do you say that, Professor? Well, notice here the slope is 1 to 1. Here the slope is 2 to 1, right? So some vertical stretching also needed. So try to figure this out, guys. And probably after this, we may go to the lecture. And in case you need help with this activity, always go back to the beginning of this lecture. Look at what we did together, and it should help you. Anybody? Yeah, very tricky, very tricky. Start with a reflection, right? It's kind of a hint. Start with a reflection. So maybe minus. Start with this and see how it looks like. Looks better, right? But then remember, this has to be parallel to this so that then you can just shift it, right? So try to increase the slope, and then shift it up, right? Yeah, very good, very good. Increasing the slope. Jing. Excellent, excellent. I think you got it. Yeah, Jing is suggesting, yeah, -2, and then +7 in the end. Excellent, Jing. I think you got it. Look, instead of minus, here -2. Another student is saying, better, right? Look at the slopes, same, right? 2 to 1, rise 2, run 1. So they match now. Better. Yeah, excellent, excellent. -2, f of x plus 1 plus 7. Gigi, you made my day. Excellent, excellent, right? So look, -2, which is good. We already saw it, right? But then for the there is a horizontal translation here, but also, look, if you just consider horizontal translation, look, almost there, right? You shifted 1 unit to the left, so now they're parallel, and not only that, they're at the same level. So you can just think of shifting this up, right? 1, 2, 3, 4, 5, 6, 7, 7 units up, right? 7 units up. That is gotten by adding 7 to the output values, right? And this is what Jinjin suggested. Excellent, look, perfect fit, perfect match, right? Perfect match. Yeah, there are 3 more challenges. You should complete them, guys, at home on your own, right? It's not that difficult as you saw. In case you don't get it at the first try, try different different approaches, right? And eventually you will get it. We will get it, and try to make sense out of the transformations. All right, great. So now I think we should go to the lecture. Okay. If you have more questions later, we can continue with this. Excellent, excellent. Yeah, this was the Desmos activity 2. Let's close it and let's go now to our lecture. All right, great. Today we're going to talk about section 2.2, graphs of linear functions. Let's start with the graph of a linear function defined as f of x equal m times x plus b. This is a straight line with a slope m and with y-intercept 0, b, right? 0, b is the y-intercept. Sometimes mathematicians say y-intercept b. It's kind of an abuse of notation, but in reality, the y-intercept is a order pair, right? But according to the context, you can consider that to be just b because it's determined by b, right? So basically, what is happening is this m is the slope. You can extract from the equation is the number attached to x, and this b will determine your y-intercept, right? 0, b will be y-intercept. Now, two scenarios to consider here. First scenario, if this m is positive, then when you graph this linear function, you're gonna get a line that will look like this, If you walk along the line, you are going up, right? Going up. And not only that, where the line meets the y-axis, that's this guy, 0, b, right? 0, b, this guy, 0, b. Now, let's talk about the slope. This is the y-intercept. Now, this is the slope m, right? Turns out mathematicians have discovered the following. If you allow yourself a change on the input values by 1 unit, what should be the change on the output values associated to this 1 unit of change on the input values? Turns out that variation is just the slope m, okay? So this is an increasing line, right? Walking along the line from left to right, you're going up. But not only that, you can say that to an increase of 1 unit on the input values, it corresponds an increase of m units on the output values. Right? So this is the powerful idea, guys. The slope is the variation associated to a variation of 1 unit on the input values, right? And kind of determines the steepness, right, the line. First scenario. Second scenario, if the slope is negative, again, here you will have your y-intercept as 0, b. But now, if you walk along the line from left to right, that's always agreement, you are going down, right? Going down. Because of that, this line is called decreasing line. Decreasing line. Decreasing line. It's a decreasing line. And again, guys, mathematicians have discovered that now to each variation of 1 unit on the x values, on the input values, right? If you allow yourself a variation of 1 unit on the input values, 1 here, what corresponds now is a variation of m units for the output values. But notice now it's decreasing m units, right? Here it was increasing, here decreasing. So let's write it out. To an increase of 1 unit, on the input values, it corresponds a decrease now of m units on the output values. Right? Try to remember this when you go over your homework. It will help you to answer the questions. Great. Now, let's do something practical now, right? Let's try to explore this idea of the slope measuring the steepness and this guy determining the y-intercept in order to graph these linear functions. Example 1, graph this linear function f of x equal 2/3 times x minus 1. How to graph this quickly? Well, notice the slope will determine what is called the steepness, right? And that is just the rise over the run, right? Rise over the run. So this guy, rise over the run. Clearly the rise is 2, the run is 3. Right? So you start by setting the y-intercept here. As 0, -1, right? 0, -1. The -1 came from here, right? Just this guy. And then from there, 0, -1, which is, let's say here. From there, you go 3 units to the right, the run, right? Run 3 units. You run always in the positive direction, and then 2 means 2 up, right? 2 up, the run. And then you connect those 2 dots, and then you're done, right? This is your graph. It's a quick way to graph this line without using tables, right? Using just the y-intercept and the slope. Here is another one for the second scenario. What if they ask you to graph this linear function now? Again, quickly, just get your y-intercept. Y-intercept will be 0, this guy 2. Set that up. Let's say 1, 2 is here. And then 0, 2, right? Look at the slope. The slope is this. The slope is equal to m, but that is just the rise over the run, right? So that's it. M rise over run. Clearly here, the run can be associated with 4, but notice the rise, -3, right? -3. So what do? From here, always you run in the positive direction. 1, 2, 3, 4 units to the right, right? And then for the rise, -3. So in this direction, 1, 2, 3, right? So let's say 3 is down here, 3 units here. So 4 units to the right, 3 units down. There you set your second point. You connect these 2, and there you have your line, right? So as you can see, is a decreasing line, right? Consistent with the fact that the slope is negative. That's all you gotta do, guys. Right? So using the slope and the y-intercept, you can quickly graph the linear functions. I want you to practice on these two, and then we will talk about parallel lines and perpendicular lines. Okay, so try to graph this guy and let me know which you think should be the answer for this. Do this first. Graph and choose the right answer there. Hint, identify the y-intercept. From there, use a slope rise over the run, and you should be good to go. Jing Jing, very good, excellent. Very good. Very good. So, can also, very good, guys. Yeah, so whenever you see a linear function, notice if you compute the y-intercept, that's given by this number, right? Whatever this number is, positive or negative, this y-intercept will be 0, positive 2, right? Great. This is this guy, right? It's right there. From there, use the fact that the slope is 3 over 5. This slope is rise over run. So from 2, you run 5 units, 1, 2, 3, 4, 5, right? Here, 5 units. And then from there, you rise 3, 1, 2, 3, right? 3. And then that's it. Draw your line there, right? Draw your line there the best you can. So that's it. Yeah, that's it. More or less this, right? Yeah, great. And then you look for this among the choices, and that is this guy. Yeah, it's a little bit farther here. Move it a little bit. That's it. Very good, guys. Excellent. Increasing, right? If you walk along the line, you're going up, consistent with our definition of increasing line. Now try to do this, number 2. And then we will talk about parallel lines. So try to graph this and identify your graph there. Hint, this guy should be your y-intercept, right? Y-intercept. Well, 0, -1. And try to remember this when you do your homework. Yeah, great. Set that up, and then from there, use the slope definition, rise over the run, go from there, run always in the positive direction, but the rise, you gotta be careful, right? Depending on the slope, you will go either up or down, right? So slope here, -2 over 5, right? Rise. Run always positive, right? But the rise is sometimes up, sometimes down. Lucero, very good. Can, very good, guys. You got it? Excellent. Yeah, let's see. Yeah, but let's check this out, right? Yeah, excellent. Very good, guys. So as we suggested, right, start with the y-intercept 0, -1 is there. From there, run 5 units. Let's use a different color. Let's say on a run 1, 2, 3, 4, 5 up there, right to the right. And then for the right, you gotta be careful. It's -2, right? So instead of going up 2, you go down 2 units, down here, the second point. And that's it. Connect these 2 dots the best you can, right? And that should be your line, right? Connect these 2 dots the best you can. Yeah, that's it. And looking through Is this guy. All right. Very good, guys. Excellent, excellent. Now, let's talk about parallel lines and perpendicular lines, okay? So we can do all these problems. Let's start with parallel lines. Then we will go nice and slowly over perpendicular lines. Okay, so first of all, two lines are parallel lines if they do not intersect. When extended, they never intersect, they never meet, right? They never meet. Sometimes mathematicians use these little symbols to state that these lines never meet when extended, so parallel lines. Now, when you look at the slope of these parallel lines, mathematicians discover that there is some relationship between the fact that the lines are parallel and the slope of the lines, right? So let's say this line 1 has a slope 1 and this line 2 has a slope 2. What should be the relationship between the slopes? Well, notice that if you consider a change of 1 unit on the input values here, the corresponding change on the output value should be M1, right? M1, according to what we studied before, right? Now, if you allow yourself a change of 1 here, the corresponding change on the output value should be also M2 here, right? The slope. But notice that these two triangles, since they are parallel to each other, they have the same angles, right? And also they have the same base, 1, right? So this have to be congruent. They have to be congruent. So M1 must be equal to M2, okay? So conclusion, mathematicians, they realize that to say that line 1 is parallel to line 2 is completely equivalent than to say that a slope of line 1 is equal to a slope of line 2, right? L1 is parallel to L2 if and only if, this if and only if in logic stands for equivalence. If and only if N1 equal N2. Notice if two lines are parallel, then the slopes are the same. But not only that, this is saying that if two slopes happen to be the same for some reason, then you must conclude that the lines are parallel, right? It's equivalence. And Professor, what's the big deal of this equivalence? Well, notice, guys, that let's say you are programming and you want to create some program to determine that two lines are parallel in a computer, right? Computers cannot draw lines, right? But they are good at comparing numbers. So what you can do is you can figure out the slope of one line, the slope of the other line, and then compare them, right? If the slopes are the same, then the program should output that the lines are parallel, right? Otherwise, the software or the program should output that the lines are not parallel, right? So it's kind of, this geometric stuff is translated into some algebraic stuff that can be implemented in a computer program, right? That's a big deal. All right, so now let's see some examples. Here, example 1 says, L1 determined by this equation, y equal 2/3 of x plus 5, and L2 determined by this equation, y equal 2/3 of x minus 20, are parallel lines since they have the same slope equal to this guy, right? Parallel lines. 2/3, right? Yeah, so these two guys are parallel. Parallel. Well, if you want to confirm that, right, you can graph these two using our Desmos graphing calculator, right? So let's see, y equal 2/3 times x. Strongly recommend you guys to confirm all your knowledge with this Desmos OER graphing calculator. Is free, and you have access to this in our website, right, for free. The other one is 2/3 times x minus 20, right? The slopes are the same, right? So the graphs should be parallel to each other. Parallel, professor, where is that parallel? Well, there you go, right? This is this line. Slope is the same. Y-intercept 5, you see here, right? 5. How do you know, professor? Click in there, 5, right? For this guy, same slope, right? 2/3, right? So we run, but the y-intercept now is just different. It's 20, right? 20, right? But they are parallel, as you can see, right? Yeah, very good, very good. Yeah, always, guys, when you need to confirm your knowledge, use your Desmos graphing calculator. Great. Okay, so we confirm that if the slopes are the same, lines should be parallel. Now let's go over this other example. So I can give you the first exercise on the worksheets. Suppose they say to you, find the equation of a line passing through the point 2, 3 and parallel to the line whose equation is this. Okay, what to do? Well, as a general strategy, I would say, go and say first, a slope of given line. What is the slope of the given line? Well, if you look at this guy here, it's just -4, right? So extract the slope of the given line as -4. Now, a slope of parallel line should be the same, right? Because remember, parallel lines, they have the same slope. So basically, we extract this guy. We don't care about this guy, right? Yeah, great. Now you're going to have this situation. Point 2, 3, because they want you to consider that point for your line, right? The line will pass through this point. And a slope -4, right? That we extracted from this guy. With these two, yesterday I showed you this point slope form of the equation of a line, right? Point slope form. Okay. And simply label this with x1, this with y1, substitute your values, and you should be good to go. The slope is -4, x minus x1 is 2. Work this out, y minus 3 equal -4x -4 times -2 plus 8, right? Finally, to express your answer in what is called a slope intercept form, just add 3 to both sides of the equation. And as a result, you will get that y is equal to -4x plus 11, right? So that's it. Very good, very good. And this is the equation of the parallel line, right? Equation of the parallel line, right? Parallel line, right? They gave you this equation, and now you have found the equation of a parallel line, and not only that, it's going through this point 2, 3, right? Yeah. If you want to make sense out of what you just did, guys, again, confirm your knowledge there, right? You say, okay, I was given this equation, y equal -4x plus 1, right? And this is this line. Now I found another line parallel to this given line, right? Y equal -4x plus 11. And then look, it looks parallel to this, right? Not only that, they say that this new line should pass through this point 2, 3. Where is 2, 3? Well, 2, 3 is here, right? So there you go. This guy, the blue one, 2. If you go with 2, associated to 2, this should show this guy, right? Associated to 2 shows 3, right? It's precisely this guy, right? Everything makes sense. Great. Okay, so now probably we should practice, right, in our worksheets, right? So remember, guys, practice makes the master. So let's practice on this part. Let's start with this. Can you try this guy? could you figure out the equation of a parallel line to this line, the one represented with this equation y equal minus 5x plus a, and passing through this point 4 comma minus 4? Can you try that? Number 3. Yeah, use any method you have in mind, right? And the hint is always pay attention to this guy, right? To this guy. This other guy, you may say, Professor, you don't use the y-intercept? No, because for parallel lines, all we care about is the slope, right? The slope, we extract the slope, we use that slope, right? The y-intercept of the given line is irrelevant. I see. Students are posting answers. Let's see. Very good, very good. Hughie and Jing. Very good, guys. Very good. Good job. Yeah, let's give a chance to others to finish. Big fact, right? Parallel lines, same slopes, because the steepness is the same, right? The steepness is the same. I remember the slope measure the steepness, and this is absolutely the same. Okay, great. Let's do it together. Again, right? Follow this little strategy, right, for the solution. Start by saying, okay, slope of given line is, what is that? Well, is this -5, right? Remember, the slope is always attached to the variable, right? The variable, so it's this -5 here, right? +8 is the y-intercept. We don't use that, just the slope, right? Just the slope. All right. And turns out a slope of parallel line, since the slope of parallel lines are the same, is also -5, right? -5. So we extract the slope. And now with this base point 4 comma -4, the line passes through this point, and this slope, it is not hard to figure out the equation of the line, right? So remember this so-called point slope form that you're going to use when you take calculus. So try to get used to this form. Labeling this as x1 is y1, this will be y minus 4, but this 4 is negative. So let me write it inside parentheses, y minus -4, y1, slope -5, x minus 4, right? 4. Let's do the math here. Minus and minus plus, so y plus 4 equal, supply our distributive property, -5x, -5 times -4 plus 20, subtracting 4 in both sides of the equation leads to this, -5x, 20 minus 4, just +16, right? Excellent. And this, guys, believe it or not, is just the equation of the parallel line, right? Equation of the parallel line. Now, guys, in case you are not sure, you want to check that this is indeed parallel to this guy, you can graph them, right, in your Desmos graphing calculator and confirm that, right? No bad idea, right? Especially if you're taking an exam, say, okay, I did the computations. I'm supposed to get a line that is parallel to this given line. Look, this red line, right? Let's see. Let's see if indeed these two guys are parallel, right? So, and guys, you're headed to exam, right? Not a bad idea to check. Look, parallel, right? The blue line with the red line never meet when extended, right? So good. This is really good. Excellent. Yeah, this one, Yeah, it's similar, but a little bit different. So probably we should do it. Yeah. Yeah. This one's. Yeah, can you try this now? Yeah, try this. It's a little bit tricky, but the equation looks like this: y equal 3x. Professor, where is the b? The y-intercept plus 0. So the y-intercept is the 0, 0, the origin, right? So just that. Try to do this, guys. A hint, pay attention to the slope, right? Extract your slope from the given line and then use the slope together with this point, right? This. And that's all you need to compute the equation of your parallel line, right? So go ahead, try. And once you're done, you feel free to confirm that with the graph or graphing calculator, right? To see that indeed they should look parallel, right? And we did with perpendicular lines also will use that to confirm our results. Yeah, find an equation for the line with the given properties parallel to the line y equal negative 3x containing the point a comma 8. Three students. Jack, you got it. Yeah, very good, Jack. Jing Jing also, excellent, excellent. Can, you are close. You Yi also close. Jing Jing, Jack, I think got it. Right, just fix it. It should be fine. Very good. All right, let's do it together. So we can see more examples. If we extract the slope from the slope of the given line, right? Then we will have that this guy, the slope should be just negative 3, right? Because this is the slope of the given line. I take it because parallel lines have the same slope, right? And there is a point there, 8,8. So using this slope and this point, I write out the equation of the line in point slope form, which is this, right? I label this guy as x1 comma y1. And then I substitute y1 with 8, slope with negative 3, slope of the parallel line, right? So, and x1 is just 8. After this, do the math carefully, right? Notice this is minus 3x, minus 3 times minus 8, positive 24, right? To isolate y, add 8 to both sides of this equation, 0 here. And finally, y equal negative 3x plus 32, right? Plus 32, which is shown on this choice B, right? And then you can confirm again this using your Desmos graphing calculator. Okay, so we're good with this. This is another one. But this deals with perpendicular lines. But let me show you one that deals with parallel lines still, but with a graph. Look, what if they ask you this type of question? I'm gonna do this one for you, and I'm gonna ask you to do the next, okay? So let's see, if they say the solid line L, this is a solid line L, right? Contains the point 4,2, 4, 2 here. So this is 4,2. And it's parallel to the dotted, this is the dotted line, right? Dotted line, whose equation is y equal to x, y equal to x. So this guy is y equal twice x, right? This. Give the equation for the line L in a slope intercept form. Okay, notice visually you can see that these two lines are parallel, right? Parallel. Look, they never meet. When extended, they never meet, right? So parallel, right? Parallel lines. Parallel lines, right? So therefore you say, okay, my slope, the one that I'm gonna work with should be just this guy, right? 2. And the point, I need a point, should be is this 4,2, right? With those two guys, then you shouldn't have a problem figuring out what is the equation of this line, right? So it's y minus y1 equal slope times x minus x1. Label this guy as x1 comma y1. Substitute everything here. Y minus 2 equal slope 2 x minus 4, which is x1, right? Do the math. This is y minus 2 equal twice x, 2 times minus 4 minus 8, and adding 2 to both sides of this equation, y equal, after canceling these two, twice x minus 8 plus 2 minus 6, right? Minus 6. And that is the answer for this question. Very good, guys. Okay, minus 6. To talk about this one, right? Great. So when you see a graph, that's how you proceed. Okay, so it's the same. Try to number 8, and then we will talk about perpendicular lines. Perpendicular, right? Try to do this. To number 8. Follow what I did before, right? Follow what I did before. Hint, they are saying that for the dotted line, this is 2,1, right? For the not the dotted line, for the solid line, or for the dotted line, they are saying y equal twice x, the equation, right? This is the point. I see students already posting answers. Jing. Yeah, you made my day. Very good, excellent, right? Excellent. Yeah, excellent. And Jing is suggesting, right? We could just use the y-intercept, slope-intercept form, and I will talk about that next, okay? Very good, as a strategy, right? Great. Excellent. Look, notice this guy has a slope 2, right? So we extract that slope, right? Since we are dealing with parallel lines, right? Parallel lines never meet, same slope. So my slope should be 2, right? 2. And the point 2,1. And in theory, you should do this, right? Y minus y1 equal m times x minus x1. Okay, but then I will mention that nice shortcut. So in theory, you should do this, right? A slope 2, x minus x1, x1 is 2. Then you should simplify this, right? Y minus 1 equals twice x minus 4 plus 1, y equal, after canceling, right? Twice x minus 3, right? Yeah, great. But now, this is the answer, right? Which is here. But now, how could you get it quicker, perhaps? Well, you can look at the y-intercept, right? At the y-intercept, right? And in this line, this solid line, the y-intercept happens here, right? Happens here at minus 3, right? Precisely, look at minus 3. You have this slope, right? This is 0, minus 3. You have the slope, y equal mx plus b, right? You have the slope, which is 2x. The b is minus 3, right? So minus 3. It can be done by looking at the y-intercept as well, right? So use whatever you have at hand, guys. Very good. So this is this. Great. Now let's talk about the perpendicular lines, right? Perpendicular, in this case. Let's go back to the lecture. And we already did parallel lines. Let's do now perpendicular lines. Okay, perpendicular lines. First of all, two lines are perpendicular lines if they intersect at a right angle. They meet, right? They meet, but not only that, they meet forming this 90-degree angle, right? 90-degree angle here, 90-degree angle, corner here, 90-degree angle. Great. Now, if you analyze the slope of these two perpendicular lines, one thing that you will notice quickly is this. If you call this line L2 with a slope M2, and you call this L1 with a slope N1, notice that if you walk along this line from left to right, what is happening? Going up, right? Going up. If you walk along this other line from left to right, what's happening? Going down, going down. So first thing to notice is that if this line is increasing, the perpendicular line will be a decreasing line, right? So the signs of the slopes must be opposite to each other. If this slope is positive, this must be negative, right? And vice versa. So this is the first thing mathematicians notice. Second thing that mathematicians notice is this. If you analyze the rise over the run on this line, rise here, run here, this is what you get, right? But if when you go over here, they kind of are related, but in this way, look, what is here the run will be here the rise, and what is here the rise will be here the run. You follow, guys? Look, this small rise will appear here, given the perpendicularity of these two lines, right? And the run here will appear in a negative direction down here, right? So two things to notice. The slopes have different signs, right? One is increasing, the other is decreasing, or vice versa. But not only that, they are reciprocals of each other, as you can see, right? That the right triangles, they appear in such a way here and here that they are reciprocals of each other. So this is what mathematicians notice, and they came up with this nice conclusion. L1 is perpendicular to L2 if and only if the slope 2 is minus 1 over slope 1, or equivalently, slope 1 is 1 over slope 2 with a negative sign up front, right? This way. Slopes are opposite reciprocals of each other, right? Two things. They have different signs, and also they are reciprocals of each other, right? This is the important fact. Now, in order for you to master how to go from the slope of a line to the slope of its perpendicular line, I have here this table that's going to help us, right? Suppose they say that the slope of your given line is 2/3. Anyone could tell me what should be, based on this fact, the slope of the perpendicular line? Anybody on the chat? Or verbally, you can tell me. And let
3
me
over
give you
2.
this. 3 over 2. But what else? What else? Something else is needed. Yeah. One first thing you have to do, you have to flip, right? But what else? The signs must be changed, right?
Negative 3 over 2.
Exactly. Yes. Very good. Very good. Very good, Jack. Negative 3 over 2, right? If the given slope is 2/3, you flip 3 over 2, but also you change the sign, right? So let's write it here so we all remember. Change sign and flip. Right? Yes. Opposite reciprocal, right? Very good. Now, what if they give you as a given a slope 1/4? What do you think should be the slope of the perpendicular line in simplified form? Anybody?
Negative 4.
Negative 4. Very good, Jack. Very good. I see on the chat, right? Jing also was right. Negative 4. Excellent, right? Yeah. And why is that, Professor? Well, because of this. If you flip this guy, you're going to get 4 over 1. But that 4 over 1 is just 4, right? And if you change the sign, this is positive, this should be negative. Excellent. Let's continue with this. What if the given slope is negative 2 over 5? What should be the slope of the perpendicular line? Anybody? Mhm. Yeah, give it a shot, guys. Yeah, yeah, Jack, excellent, excellent, right? 5/2, right? Two things that you must do to the given slope. You have to flip it, right? 5/2, and you have to change the sign. This is negative, so this guy will be positive. You will have to write a positive sign, right, when that quantity is positive. So it's 5/2. Excellent, excellent. One more, 1. What if the slope of the given line is 1? What do you think should be in simplified form the slope of the perpendicular line? Anybody?
-1.
Excellent, excellent, Jack. -1, right? Why you say that, Professor, -1? Well, because this guy is indeed just 1/1. And if you flip 1/1, you get still 1/1, but we must change the sign. So we will get -1/1, but -1/1 is just -1, right? Excellent, excellent. This is a tricky one, guys. What if they give you as a slope of the given line 0? What if your line is horizontal? Remember when you're at the top of the mountain resting, slope 0, right? What should be theoretically the slope of the perpendicular line? And as a hint, I can tell you it's not going to be a number, but what should you write here? Anybody? Feel free to give your best. Remember what you get when you try to divide 0 into something, 1/0. What is that? Anybody? 1/0? Look. I see someone is writing on the chat. Undefined. Jing, you got it. Undefined, right? Remember, for vertical lines, remember you cannot go against the mountain. This is a slope undefined, right? Undefined. So you are here, undefined. And vice versa, right? If they give you something undefined, you will have to say that this is 0. Great. There's a last slope here. What is the slope? Is 1/3. What should be in simplified form the slope of the vertical line before we go into exercises? Very good, guys. Jing. Very good, excellent, right? Yeah, if you flip this guy, you're gonna get 3/1, but I see it's gonna be 3, positive here, negative here, right? So -3. Excellent, excellent. Okay, guys, now that you are you have mastered how to go from the slope of a given line to the slope of a perpendicular line, let's try to do some exercises. First exercise, and try to remember this for your homework. They are giving you 2 lines here, right? And by looking at their slopes, you can say something. Look, notice, since -1/5, when flip and change its sign, flip becomes 5/1, right? Which is 5, which is this guy. Then the conclusion is L1 and L2 are perpendicular, Now, notation for this word perpendicular, you know, mathematicians are minimalists. They like symbols, right, instead of words. So you may see this symbol here, perpendicular. This symbol showing a corner here means perpendicular. So when you see, for example, M followed by this symbol, it means a slope of the perpendicular line. We're going to use that. Okay, great. So these lines are perpendicular because one slope is obtained by changing the sign and flipping the other, right? Very good. Example 4, computational example. It says, find the equation of the line passing through this point perpendicular to the line whose equation is y equal -1/4 times x plus 2. Let's do it together. Okay, notice, guys, that in this case, the slope of given line is this guy, right? The number attached to x is -1/4. But now, what should be the slope of perpendicular line? Anybody could tell us? And as a hint, 2 things that you must do to this number: change sign and flip, right? Always these two things. Yeah, so, I see. Jack, you got it. Yeah, excellent, right? Yeah, when you flip, this will be 4/1, which is 4. And when you change the sign, it should be just 4, right? Excellent, 4, right? Change the sign and flip 4. So this is the slope I gotta work with now. No longer with this, right? But with this is the slope I gotta work with. So what you do is you say, okay, now I am gonna be in a better situation because now I will have a slope to work with, a slope 4, right? And this is gonna be, to be precise and to avoid confusion, is gonna be the slope of the perpendicular line, right? But remember that little shorthand for perpendicular I show you? So a slope of perpendicular line 4, right? Great. And the point is this, right? They want your perpendicular line to go through this point. So with this slope and point, we have a way to compute the equation of the line, right? So I'm gonna use point slope form for the equation of the line. I'm gonna label this guy as x1, this second coordinate is as y1. Substitute everything here. Y1 is 3, slope of the perpendicular line, be careful there, right? For x minus x1. X1 is -2. Use parentheses when you substitute negative numbers, right? So I will end up with this. 4 times x is 4x. Negative and negative positive 2 times 4 is just 8, right? And adding 3 to both sides of the equation, I get the equation of the perpendicular line to be y equal 4x plus 11, right? 11. And this is going to be, guys, believe it or not, the equation of the perpendicular line, right? This is the equation. Of the perpendicular line, right? Now, you may say, Professor, can I just double check that that's the case? Well, if you want to double check, graph this line and graph this line together, and you must see that they must intersect, forming a 90-degree angle. Let's check this out, right? Let's bring out our Desmos graphing calculator, and let's confirm this, okay? So, so let's graph first, y equal here, negative 1/4 times x plus 2. This is this red line, right? Now let's graph the one that we just got, y equal 4x plus 11. And you can see, right, that they meet, right? And not only that, they meet forming a corner, a 90-degree angle, right? You can see it there, right? So all check, so you are good, okay? Great. Next, let me ask you to do something on the worksheet, right? We're gonna go over different forms there. So start with this, guys. This one is good. Could you figure out, I think this one is better, number 6. Will you figure this out? Number 6. Yeah, go ahead. Find the equation of the line that is perpendicular to this line, the one represented by this equation, passing through this point. Okay. Number 6. Yeah. I will give you some time. Now, there's going to be situations in which you may have to deal with additional fractions. Try to remember how to add fractions using the LCD, right? But also, you can use your calculator and help yourself with that. I will show you, okay? But try this one first. Let me see what you get. That's a good example. See, students are already figuring this out. Aha, Jing Jing. Excellent, great. Yeah, let's wait for more students to figure this out. Yeah, just do the computations carefully and that's all right. Hint, pay attention to this slope of the given line, right? But since now we are dealing with perpendicular lines, we gotta do two things to this, right? We gotta flip and we gotta change its sign, right? Yeah, okay, remember that. And sometimes the students ask me, right, Professor, there is a +9 here. Do we ever use this number? Turns out we don't use the y-intercept of the given line, right? We explained that before with the parallel lines. This guy is not used for this problem. Only the slope is the one that we use, right? So don't worry about this. All right, let's work this out together, okay? Again, as a general strategy, I would suggest this. Start by figuring out the slope of given line. The slope of given line is just this guy, right? 1/9. Now, figure out what is going to be the slope of perpendicular line, right? I'm going to use this symbol to represent the word perpendicular line. What is that? Is, well, two things that you must do to this guy, right? You have to flip this guy. And not only that, you have to change the sign, right? So this will become minus 9/1, but 9/1 is just -9, right? So conclusion, with a slope -9, and this point, the slope, this of the perpendicular line, right? -9, and 0.5, -4, using our point slope form, we should get the following, right? This label it with x1, this one with y1, and go ahead and say y minus y1, y minus -4. Be careful when you substitute negative numbers, use parentheses, right? Equal -9 times x minus x1, which is 5, right? Minus or minus plus, so y plus 4 equal -9 times x, -9x, -9 times -5, negative and negative positive, 9 times 5, 45. And subtracting 4 from both sides of this equation, you just end up with this y equal -9x, plus 45 minus 4, 41, right? 41. Excellent, excellent. And this is just the equation of the perpendicular line, right? This equation of perpendicular line. Yeah, try to remember this for your homework, guys. Great, this guy. Yeah, excellent, excellent. This one is a little bit tricky, but deals with fractions. Yeah, try to do this. So we will move to the one with the graph then next after that. Figure out the equation of a line perpendicular to this line, the one represented with this equation, y equals 6x plus 4, and passing through the point 0, comma, -5. Yeah, then we will the ones that comes with the graphs, right? Yes, it's the same idea. Number 5. Jin. Excellent, excellent. Good job. Yeah, very good, very good. Yeah, let's wait a little bit for others to complete this. Practice, guys. Similar questions are gonna come on your exam, okay? So make sure you're gonna be okay with different forms, right? The whole idea. And as I said, right, whenever you wanna check that indeed you are getting a vertical line, use your Desmos graphing tool and make sure that they're perpendicular, right? Otherwise you have to fix your answer. Can. Very good, Can. Very good, very good. Excellent, excellent. Yeah, great. Yeah, sometimes I said you may have to work with fractions, right? Yeah, but it's okay. I will show you. Here we see that we are looking for a line which is perpendicular to this, right? So you start by saying, okay, a slope of given line is this guy, 6, right? 6. Therefore, then a slope of perpendicular line is what? 2 things you do to this number 6, right? Which is equivalent to 6/1. You gotta flip this guy. As a result, you will get 1/6. But not only that, the sign here is positive. You gotta change it to negative, right? Flip and change sign. So believe it or not, negative 1/6 is the slope of the perpendicular line. So with the slope of the perpendicular line equal to negative 1/6, and with this point, which is very special, it's just the y-intercept, right? You can find easily your equation following this point slope form. X1 comma y1. So y minus y1, which is -5, will be equal to the slope of the perpendicular line, which is 1/6 negative, x minus 0. This is a nice number, 0, because disappears, right? So y minus and minus plus 5 equal minus 1/6x. Subtracting 5 in both sides, you're gonna get here that y is just equal to negative 1/6 the slope times x minus 5, right? And this is the equation of perpendicular line, right? And again, if you want to confirm that this is indeed perpendicular with this, you can graph these two and you will see that they are indeed perpendicular, right? Yeah. Okay, great. So this is this guy. So now let's talk about the form that deals with a graph, right? Yeah, this is this. Very good. Let me show you this one. This is with parallel lines, but we should do it with perpendicular lines now, and then you will do the next, okay? Let's talk about this. Suppose they say, right, the solid line, this one solid line, right, L, let's call it L, contains the point -1,4. -1, 1 to the left, 4 up. This is the point -1,4, right? And is perpendicular. They're telling you, right? It's perpendicular to the dotted line, which is this, right? They form a 90-degree angle when they meet, whose equation is y equal twice x, right? This is the equation of this dotted line. Give the equation of the line L in a slope-intercept form, right? Equation of the perpendicular line. So we start by figuring out the slope of this dotted line, right? Which is 2, right? So slope of given line is 2. Then a slope of the solid line, the perpendicular line should be what? Well, we do two things to this, right? Flip and change sign. Okay, so you do that. Flipping, we're gonna get 1/2. Changing the sign, minus 1/2, right? So believe it or not, guys, the slope of your perpendicular line should be equal to minus 1/2. Now you have a point. What point, Professor? This guy, right? -1,4. So use that point, right? Use that point for your point slope form, right? For the equation of this line. And that should be it, because this will be y minus y1, which is 4, equal slope 1/2 negative x minus -1, right? See someone writing something on the chat? Let's see. Kang. Yeah, Kang, I think you're talking about this 9. Yeah, you are headed there. We're headed there for 9. Excellent, excellent. Very good, Kang. Very good. Excellent, excellent. Yeah, great. So now you see here, right? And let me show you here something. Minus 1/2 times x is minus 1/2 x. But now, what is this times this? Minus and minus plus, this is plus 1. Negative 1/2 times plus 1 is negative 1/2, right? Negative 1/2. But here now, when you add 4 to both sides, what's going to happen here? Look, this disappears. Y by itself here, minus 1/2 x, minus 1/2 plus 4, minus 1/2 plus 4, right? But what's that? What's that, Professor? Minus 1/2 plus 4. If you use the LCD after placing 1 below 4, LCD of 2 and 1 is 2, right? LCD 2, which means that we have to multiply denominator and numerator by 2 to make the denominators equal to the LCD, right? So multiplying both by 2, we get this, right? Minus 1/2 plus 2 times 4, 8 over 2. Common denominator 2, minus 1 plus 8 on the top. But minus 1 plus 8 is 7. So this should be 7 over 2. 7 over 2, right? So that 7 over 2 is what you gotta write here on the numerator, plus 7 over 2. Professor, a lot of things to do there with dealing with these fractions. Is there a way we can get this quicker? Answer yes. If you want to avoid doing this thing, one thing you can do to get the equation of your perpendicular line is this. When you have to add this, you have the decimal scientific calculator, right? This is the grapher. Let me bring the decimal scientific calculator, which is this. There, you can do this. You can do minus 1/2 plus 4, right? What is that? Minus 1/2 plus 4. What's that? It gives you the decimal representation first, right? But then if you click on this circle, convert to fraction, it will give you the 7/2, right? You follow, guys? If you can do it in your mind using LCD, follow this. But in case they say this is not working, don't get stuck. Go to the calculator, do minus 1/2 plus 4. It will show you first the decimal version, but if you click here, it will give you the fractional version, right? You follow, guys? One way or the other, get it done, don't get stuck. All right, so that's it. And this is this guy, right? Very good guy. Excellent. Can you try now this one? Try this one on your own. Follow what I did, guys. And again, if you encounter these fractions, to alleviate the algebraic part or the arithmetic part, just follow either the use of the decimal scientific calculator or add them using the LCD. Okay, try this one, guys, please. And then we will go over a complicated form in the bottom. I see some movement in the chat room. Let's see. Yeah, remember, this is the point 4,3, right? And this is the line L perpendicular to this dotted line. Let's see, number 10. Jing Jing, excellent. Kang, good work, guys. Yeah, always practice, guys. Practice in mathematics, practice makes the master. Okay, great, very good. So, again, right, they are giving you two lines that are perpendicular to each other. They are giving you 1 point on this solid line. They are telling you that the equation with this dotted line is y equal twice x, which allows us to quickly extract the slope of the given line, right? So the slope of given line is 2, right? 2. Coefficient or the number that appears in front of the variable x. But now I am interested in the slope of the perpendicular line, right? Perpendicular line. What that should be? Well, I have to do two things to this number 2, right? Flip, and change sign, right? Because remember, slope of perpendicular lines are opposite reciprocals of each other, right? So change sign here. Okay, change sign. So if you flip 2 over 1 is 1/2, but if you change the sign, minus 1/2, right? Minus 1/2. And then you do y minus y1 equal a slope of the perpendicular line x minus x1, right? Label your point, this point, as x1 comma y1. So from there, bring y1, which is 3, down here is slope negative 1/2 x minus x1, 4, right? Let's do the math carefully here. Y minus 3 is just, y minus 3 is just equal to minus 1/2 here, x. And do these computations carefully, guys. Minus 1/2 times minus 4, minus and minus plus 1/2 times 4, 2, right? 2. And then here, adding 3 to both sides, we get that y is equal to negative 1/2 x plus 5. Negative 1/2 x plus 5, which is here. Excellent, guys. Somehow we got lucky. The fractions did not appear there, right? But you know what to do if they do, right? Great. So for that purpose, I have to go over this, and this, the last two. Number 11. Try to do number 11 now. Number 11 and 12. Yeah, we gotta go over these two. Yeah, especially number 12. But let's do number 11 first. Can you try this? But this is with parallel lines. Yeah, I'm doing this because I want to explain what to do. Yeah, maybe I should show you this, what to do when the equation of the given line is given in this form. This form, for you to know, guys, is not so common, but mathematicians call this form, it's called general form. This form is called general form of the equation of a line, general form. Okay, and they are saying, right, that you are supposed to find the equation of a parallel line to this line whose equation is given in general form, right, and passing through this point. So what to do if your equation is given in general form? Isolate y. Isolate y. Why isolate y, Professor? Well, because if you isolate y, then you will get the form that you want, right? The slope intercept form. So bring this number 5 to the other side, transpose it, changing the sign, or simply add 5 to both sides, you get this, right? But also do that with this negative 9, with this 9x, subtract 9x in both sides. And as a result, you are gonna get, after canceling these two, that y is equal to minus 9x plus 5, right? This is now in a slope intercept form, the form that we are used to work with, right? I see Jack figure this out. Let's check, Jack, what you did there. Good, excellent, very good, we're headed there. Yeah, so now that you have this, everything comes back to normal, guys. Don't get freaked out if you get this general form in your homework. Just isolate y and then everything will come back to normal, because from here we know that the slope of the parallel line will be -9, because parallel lines have the same slopes, right? So work with this slope and with this point. The point is 5,2, right? 5,2. It's going to be x1, y1. And just apply this y minus y1 equal slope times x minus x1. Y minus y12 equal slope -9 x minus x15, right? Do the math here. Y minus 2 equal -9x, -9x, -9 times -5 plus 45, right? And adding 2 to both sides of the equation will show that y equal -9x plus 45 plus 2, 47 is the equation of the parallel line, right? Parallel line. So this is it, and this is this. Very good, very good, Khan. Okay, finally, let me finish with this guy. Try to do this now perpendicular general form, but you know what to do, right? Yeah, I'm gonna give you some time. Right? The hint is, since they are giving you the equation of the given line in general form, hint, isolate y first. Isolate y. Get y by itself. From there you get the slope. Then you do flip and change sign of the slope to get the slope of the perpendicular line, and you should be fine. Now you may say, Professor, I see scary fractions there. I show you, right? In case you cannot add them using the LCD, use the calculator. It can help you. It can help you. Okay. So try to finish this lecture. Notice keyword here, they're saying it's perpendicular, right? So let's mark this guy with perpendicular, no longer parallel. And also, this is in general form, right? Yeah. Equation in general form. Yeah, on the homework, you may encounter these things. Don't get freaked out. It's just isolate y, and then everything should come back to normal. Aha, I see. Lucero, Jing. Aha, you guys made my day. Yeah, very good, Lucero. Excellent, excellent, right? Yeah, there's gonna be some fractions there, but don't get freaked out. I show you how to deal with them, right? Yeah, very good, very good. Can also, excellent, excellent. Good job, guys. So let's do this together. All right, the equation of the line, the given line is given in general form, but that shouldn't be a problem because we know, or we have a strategy to deal with this form, which is move everything to the right except for the y, right? So transpose 6 to the other side by adding 6 to both sides. This will give you minus 3x plus y equals 6. Transfer this to the other side, changing its sign, or equivalently add 3x to both sides, right? Same idea. So here, y should be equal to what? Write this first, 3x, the constant at the end, right? There you can see that now from general form, we went to a slope intercept form, right? Which is the form we are used to. So there simply extract the slope, right? Extract the slope. Say, okay, the slope of given line is, and you just write this guy, 3. But now we're dealing with a perpendicular line, right? So then according to our properties, a slope of perpendicular line is what? Well, I get this. We have to flip and change sign, right? Flip and change sign, this. All right, so if we flip, we're gonna get 1/3, right? Because it's 3/1. And if we change the sign, we will get minus 1/3. That will be our slope, right? Minus 1/3. Now, we have the slope minus 1/3. And we have a point, so minus 1/3. We have a point, the point is given somewhere here, 2,5. But now what is left is simply to figure out the equation of this line, right? But for that, I'm gonna use point slope form. So 2,5. This guy x1, comma y1. So y minus y1 equal m perpendicular line, slope of the perpendicular line, x minus x1, right? Y minus 5 equal a slope. We said that the slope is negative 1/3 times x minus x1. X1 we are saying is 2, right? And let's do carefully this. Y minus 5 equal minus 1/3 times x. A lot of algebra there, guys, but it's just the way it is. Negative and negative positive, 1/3 times 2. 2 times 1 is just 2. 3 times 1 in the bottom here, 3, right? This is what we get. And now, guys, once you add 5 to these two sides of the equation, this is 0. Y equal what? Minus 1/3 of x plus this. A sum of two fractions again, right? I'm gonna do this here first manually, right? 2/3 plus 5. Remember, 5 is the same as 5/1. If you take the LCD of 3 and 1, that's just 3, right? LCD. So we are dealing with 2/3 plus 15/3. Common denominator 3, 2 plus 15, that is just 17/3, right? 17/3. That's what goes here. 17/3, right? But now let's say it's too crazy to do this in your mind. You need help with your calculator. You can also do this with your calculator. Look at this. Check this out. 2/3, right? Plus 5, right? I'm talking about this computation, right? 2/3 plus 5. Initially, our decimal scientific calculator will show us the decimal version of the result, right? Which is this crazy, never-ending decimal part. But if you click in here, you convert this to fraction, 17 over 3, right? 17/3, which is there, 17/3, right? So one way or the other, guys, don't get stuck, right? If this doesn't work, use your calculator, right? This is good. And this is telling us that the answer for this 12 should be just the first one, this one. Excellent.